What's going on, everybody? Mr. Perry here. Algebra 1, last video, last week of the school year, week of June 1st, 2020. This is our polynomial unit, and we've been going through a bunch of different types of factoring over the last month, whether that be the GCF or factoring with difference of squares, or what I would call the ABC method, where we had our quadratic trinomials. So we're going to go ahead and just, for this last week, review all of that different type of factoring. It is very important when it comes to the rest of your classes, especially Algebra 2, kind of hit it up again. So I want to take a look and see what it is or when it is that we want to use different types of factoring methods. Got an assortment of different polynomials circling that, and we're going to go through each of those to kind of pick out and talk about exactly how it would be that it would make sense to what it is, which method we would want to go with. But some of the helpful hints here, we always want to check for the GCF first. No matter what, we see a question that says factor, blah, 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 boom. We see that word factor, we want to make sure we check for the GCF first. That's our greatest common factor. Secondly, we want to look and see how many terms there are for us here in Algebra 1. We dealt with a lot of 2 terms and 3 terms, specifically when we got into difference of squares in our ABC method that we just did last week. So we want to take a note of that also. Of course, with difference of squares, we're looking for a minus sign when it's ready to get factored. But that's the 2 things that we want to kind of make sure we check for each of these. So I'm going to go through a bunch of examples here. The first of which I see I have factor 8x to the third power minus 4x squared. And when it comes to things that I want to check for the GCF. You're going to circle this GCF every single time. And then, we also want to check here for difference of squares. I see 2 terms. That's a binomial. All right, so that kind of eliminates our ABC method. We're not going to worry about that. We're going to be checking out difference of squares, but that's after we focus on the GCF. So 8x to the third power minus 4x squared. Do they have any factors in common? We take a look at the coefficients 8 and 4. Are there any factors in common between 8 and 4? And hopefully you already know that that is the number 4. We can divide 4 from both of those. What about those variables? We have x to the third power. We have x squared. Obviously, they're both x's. They have how many in common? They have 2 in common. So I can go ahead and take out an x squared. If I divide that out, if I factor that out of our original binomial, 4x squared, that's our GCF. So it did have a GCF. I can now go ahead and factor that out. 8x to the third power divided by 4x squared. 8 divided by 4 is 2. X to the third power divided by x squared would just be x. There's 1 x left over. We have a 4x squared. 4 divided by 4 is 1. Go ahead and put a 1 there, even though you really don't need that 1. Kind of a placeholder. And x squared divided by x squared would be 1 also. It's the same thing divided by itself. Okay. Now you might notice here inside the parentheses we have a binomial still. That's where we want to check our difference of squares. All right. Do we have a difference? That's the first thing we should always figure out. Do we have the difference? We do. There's a subtraction symbol right there. And then we'll go through each of the parts of these terms here in this binomial and check out and see whether or not we have a perfect square. We get to the number 2. Is number 2 a perfect square? No, it is not. So we do not use a difference of squares here. By the way, x is not a perfect square. 1 is. 1 is a perfect square, but not 2, not x. So we can't do difference of squares. So when it comes down to it, the final factored answer simplification to the original would be 4x squared times the quantity 2x minus 1. We move on to the next one. Factor 9x squared minus 16. Looks kind of similar to the one we did before. And we'll go ahead and we'll say that, of course, we want to check for a GCF first. I see 2 terms there. There's a binomial. So we'll go ahead and check for difference of squares also. We're not seeing a trinomial here. We're not seeing 3 terms. We're seeing 2 terms, the 9x squared and the 16. So we're not going to use our ABC method with the quadratic trinomials and trying to factor that out. Can we pull out a GCF? Is there any terms in common between 9x squared minus 16, 9x squared and 16? 9 is divisible by 1, 3, and 9. 16 is divisible by 1, 2, 4, 8, and 16. So when it comes to the coefficients, the numbers involved here, there's no GCF. And the first term has a couple x's. It has two x's, x squared. The second term does not have any x's at all. So actually, in this case, we don't have a GCF. That's just a reminder here that you want to make sure you check for a GCF here. Then we're going to go ahead and check out for a difference of squares because we see a binomial here. So is there a difference here? Yes, there is. We see a subtraction symbol between the two, 9x squared and minus 16. Are they all, everything we see there, every part of every term, does it have perfect squares? So can we do the square root of 9? Sure, that gives us 3. What about x squared? What would be the square root of that? Well, that's x. What about 16? Is 16 a perfect square? It is. 4 times 4 would be that. So we have a difference. There's a minus sign in between. And each of the parts of our terms have a perfect square involved. So we can go ahead and factor this out. We want to make sure it kind of looks like we've referred to FOIL before. These symbols in between, we want to make sure they are different. So we have the quantity 3x minus 4 times the quantity 3x plus 4. That right there is as simplified as it can go. If we have to factor it out, 9x squared minus 16, that would be our simplified answer right there. Moving on, we got a factor x squared plus 10x minus 24. That definitely looks a little bit different than the previous ones. Of course, it says the word factor, so we're going to at least check for GCF. And we have 3 terms here, not 2, 3 terms. So I want to focus on checking for the ABC method, especially because I see that quadratic, especially because my biggest exponent here is the number 2. So kind of went along with that in the difference of squares here. But we see our biggest exponent here is 2, so we want to go ahead and roll on that also. We'll go ahead and check for a GCF. Is there any terms in common, any factors in common between x squared, 10x, and the 24? Well, if we're just looking at variables, x squared has an x, 10x has an x, the 24 does not. I don't want to put an x there because that would be confusing. What about the coefficients in the front? Here's the number 1, there's 10, there's 24. You know, of course we can divide all those by 1, but there's no number above that. So here, while we're checking for a GCF because it says the word factor, there is none in the problem. Next up, we want to check for the ABC method. Remember that that's kind of looking at any quadratic trinomial as the following here. So when we talk about A, B, and C, we know our A value is 1, our B value is 10, and our C value here is negative 24. And can we come up with 2 numbers that would multiply to C, which in this case is negative 24, excuse me, and add to B, which here is 10. Now the C is negative, so we have to have opposite symbols here. This is what we went over the week prior to this, so hopefully this is fresh in your mind. And the numbers that you should come upon as you're thinking about this, you know, 1 and 24, 2 and 12, 3 and 8, 4 and 6, there's plenty here for 24. And hopefully you come to the point where you recognize that if I take the numbers positive 12 and negative 2, if I multiply them together, it's negative 24. If I add them together, 12 minus 2 technically is 10. So that right there are the 2 numbers that we want to lock in on. We want to make sure that kind of looks like a FOIL problem from before and multiplying those binomials to one another. So again, uh, that is as far as we can go if we're trying to factor x squared plus 10x minus 24. That is our simplified answer. The quantity x plus 12 times the quantity x minus 2. All right, next one up kind of looks similar to the last one because we see three terms. This does say the word factor there. So we want to make sure that we're checking for a GCF. There is not two terms, but there are three terms. So we're going to go ahead and at least check for the ABC method once we get done with this. Take a look at the GCF here, if there is any. I got 2x squared. I got a negative 14x. I got a positive 20. When it comes to the variables, that 20 does not have a letter x, so that's a problem. When it comes to the coefficients, 2, 14, 20, all divisible by the number 2. So we can go ahead and we can't pull out any variables, but we can definitely go ahead and take out a factor of 2 from every single thing in the problem. So we do have ourselves here GCF. It's a good thing that we spend some time checking for it, and we know that it's 2. So 2x squared divided by 2 would be just x squared. Negative 14x divided by 2 is negative 7x. And 20 divided by 2 would be positive 10. Now we're going to go ahead and take a look. We factored out a GCF. We're going to take a look inside this parentheses. That right there is a quadratic trinomial. There's three terms inside the parentheses. The biggest exponent is 2, so it's in play for our ABC method here. We want to go ahead and check and see if we can find two numbers where they would multiply to positive 10 and add up to negative 7. So not too many factors here of 10, 1 and 10, 2 and 5. But please remember that we could also, in this scenario here, we'll take negative 1 times negative 10 and negative 2 times negative 5. And if we check that out, hopefully we come to a point where we recognize, hey, negative 2 times negative 5, that would be positive 10. Negative 2 plus negative 5 would be negative 7. That's our two factors that we're going to kind of hone in on here. And if I go ahead and write that out, I got x minus 2 times the quantity x minus 5. That would give me the above scenario here. But, and this would be the one spot where I think a lot of people kind of mess up on from time to time, don't forget that GCF. Right, we want to have that GCF in front. Spent that time earlier on working on it. Let's not forget it. So as factored as possible here, it actually worked out that we had the GCF and the ABC method involved here. Our final simplified factored form would be 2 times the quantity x minus 2 times quantity x minus 5. That's as far as we can go with factoring for this particular problem. I'll go ahead and wrap it up here. We got, it says factor 5x squared minus 45. So we definitely, of course, wrapping this up, hopefully you recognize every single time I see the word factor, I should start off by checking for a GCF. There are two terms here. It's a binomial. So we want to go ahead and eventually we'll talk about difference of squares potentially in this problem. But before that, we got to worry about the GCF. I got two terms here. I got 5x squared. I got a negative 45. You can see that negative 45 does not have an x involved. So for variables, there's nothing for the GCF. However, both are divisible by the number 5. So we can go ahead and count that as our GCF. We do, in fact, have a GCF here. We'll pull that out, and whatever's left over, we'll write down in parentheses. So 5x squared divided by 5 is x squared. And negative 45 divided by 5 would be negative 9. Pulled out that GCF, and now I want to take a look inside that parentheses and see if I can go further with that. X squared minus 9, it's a quadratic. It's two terms, it's a binomial, so we can check for difference of squares. Is x squared a perfect square? Yes, it's x. Is 9 a perfect square? Yes, it is. We would get 3 if we square rooted it, and we did say that from the get-go we did have difference here. We had a minus sign. If it was a plus sign, then we really can't do anything with it. But since there's a minus sign, we can try for the difference of squares. We have an x, we have a 3 from what would come from square rooting those terms. So we want to go ahead and write that out. Again, we should have opposite terms in these parentheses, x minus 3, that quantity times the quantity x plus 3, that would give us x squared minus 9. Please, 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 please do not forget the GCF from the beginning in the front. So if we were to ask factor 5x squared minus 45, the most simplified factored way you could write that out is 5 times the quantity x minus 3 times the quantity x plus 3. So again, in review, you always want to make sure that you check for the GCF first, no matter what. If there are only 2 terms in the problem, it's a chance you want to maybe take a look at difference of squares after the fact. Remember, it has to start off by being a difference. So if you see a plus sign in there, it's kind of nullified as it is. Also, if we have a trinomial, we want to try that ABC method that we did last week, where we're looking for two numbers that would multiply to the C term and add up to the B term.